And then, unfortunately, this is a case, and that's what I will be discussing. Right? So, if it is nonsense. So the problem is when B and is nonsense. It is known, though, many properties of Bn are known. So first, Bn is, let's say, has minus canonical class, has minus canonical class is ample, minus canonical class is ample, even single, and singularities are mild. Singularities are mild, KLT. And in fact, there is a very particular structure on the complementary of delta. So if delta inside Pn is always a divisor, such that for T inside delta, the preimage is singular. Then on the complementary Pn minus delta, there is an affine structure. An affine structure. That means we have local coordinates, and the transformation is affine in G len. Okay. Maybe I just mentioned what it is. I think it is kind of clear. That means you have a covering. So Pn minus delta is a complicated domain, yes? So in principle, it's a big affine variety. However, it can be covered by local coordinates so that all transformations are simply affine. Affine, and moreover, affine with coefficients in integers. Which is not that, how to say, in a way it is not that difficult, because if you look at the fiber, e to the power n, then its neighborhood. So there's standard coordinates on a torus, and by duality they give standard coordinates on the base, or vice versa. So therefore you have a monotony which maps torus into itself, and at the same time by certainly integral transformation, even in SP. Then, in the same way, it will map local coordinates into simple local coordinates. So by duality and the fact that it is Lagrangian provide these manifolds for investigation of the structure.
So are fibrations as a trivial?
Sorry?
Your fibrations, are they always as a trivial? So you want all tori are isomorphic as complex variations?
No. It's variation of structure. It's in almost all cases. I don't remember if it is all. There are theorems which tell you that yes, you have a torus, but the structure varies maximum. So basically, when you have a variation, it's maximal variation. It's not constant at all. There is no constant direction. So you have a torus with varying complex structure.
And still you have monodromy. Still you have monodromy that coordinate-wise monodromy.
Yeah, so when you approach device, it's like an elliptic fibration. You have all kind of elliptic curves. When you approach singular points, you have a non-trivial monodromy. So in the elliptic case, it's 1 and 1, 1, 0. That's a monodromy in a special fiber, basically. At least for the one which I described, and that's exactly the picture, but this also proved, the analog of this result is also proved in high dimension. That monodromy is exactly like that. So many things are proved, and it's just kind of slowly approach. So if you would know that there is only, I think, I'm not kind of, okay, so if you would know that the the manifold is smooth, and we completed it for P2, and some other people also did for dimension 2. In dimension 4, we know that it's P2, and therefore many things can be done. At least something like finiteness. Okay. Okay, I think my time is up. Yeah. Okay, thank you for attention. I will continue.
Are there any questions? Yes.
Yes.
Would it
Yeah.
take long to say a couple of words about the 6 and 10 dimensional examples?
Well, it's essentially modular spaces on surfaces. On Kessler, some special modular spaces on Kessler. So the only problem is many spaces. You can organize spaces of modeling of vector bundles. So that on the open part you have a natural holomorphic form, like it happened, for example, for Kessler surface. For many modular spaces, you take bundles with deep prescribed kind of Chen classes. And then just by that, by the counting, you can see that there, in some natural duality, you can see that there is a holomorphic space on the open part. The problem is the completion. So you take modular spaces, yes? For example, you take spaces of bundles. But in order to make it projective, you have to add some kind of shifts. It's never compact naturally in high dimensions. Okay? So you take modular spaces, you move bundle. And then, in the closure of the bonds, you have a strange torsion free shifts. And usually it is a problem how to extend holomorphic forms through the symbol. And sometimes it's possible, but certainly after already many people tried it in other cases. It doesn't work. So you have a variety which is on a smooth path, has a good symplectic structure, symplectic form, non-degenerate, but you try to compute it, to complete it, any smooth completion, it fails.
Are there any more questions?
So this completion just fails, or it is proof that it doesn't exist?
Sorry?
This completion just the attempts fail, or it is
Attempts fail.
But it's not proven that.
No, it doesn't. No, now it is open. We don't know what are the varieties. What can be such compact varieties? Compact hyperkahler. Yeah. So current attempts are for this variety that we saw already in the beginning of the ages, and since then O'Grady was the only one. So certainly.
Okay, so this will continue tomorrow, second part. If you don't have any more questions, we thank you, Mekan.
Yeah.